So hi, in this video we will be discussing integration of integrands that lead to inverse trigonometric functions. Okay, so for this topic we will be memorizing the integration formulas. Okay, so we have the integral of du over square root of a squared minus u squared, where a is a constant. Okay, so that is equal to arc sine of u over a plus c. Okay, so we also have the integral of du over a squared plus u squared is equal to 1 over a arc tan u over a plus c, and integral of du over u square root of u squared minus a squared is equal to 1 over a arc secant of u over a plus c. Okay, so here the numerator should be the complete differential of u. Okay, so whenever we find an integrand, okay, that looks like any of these three, then we should consider integrating it using inverse trigonometric functions. Okay, so let's have some example problems. So example number 1, so we have find the integral of e raised to 2x dx all over square root of 9 minus 4 e raised to 4x. Okay, so in this problem, so this looks similar with the first formula, right? Okay, so let's try using arc sine for this problem. So but first let's express it in the form a squared and u squared so that we can find our a and our u. So this is equal to the integral of e raised to 2x over square root of 9 is 3 squared, right, minus 4e raised to 2x, 4e raised to 4x, that is 2e raised to 2x squared. Right? Okay, so don't forget the dx. Okay, so therefore for this problem our a is equal to 3 and our u is equal to 2e raised to 2x. Okay, so remember that to apply this formula, the numerator should be the complete differential of u. So we need to find du. So du is equal to, so differentiating this, so that will become 2, then derivative of e raised to 2x, so copy e raised to 2x, and then multiply it by the differential or derivative of the numerator, so we have 2 and then dx. So therefore our du should be 4 e to the 2x dx. Okay, so as you can see, again, this should be the numerator, okay, because this is du. Okay, however, in our numerator, we can see that we only have e raised to 4x dx. So therefore, we must write 4 here as the coefficient to complete the differential, and then write 1/4 or the reciprocal of 4 outside the integral sign. So this will become integral of e raised to 2x dx over square root of 3 squared minus 2e raised to 2x squared. So again, we have a missing here of 4. So outside the integral sign, we must write 1/4. Okay, so the differential is now complete. Then we can now apply the formula arc sine of u over a. So this will become 1/4 arc sine of u is 2e raised to 2x over a, which is equal to 3, and then plus c. Okay, so that's how simple it is. Okay, so for our next example, so I have rewritten it because I copied the wrong problem. So we have integral of x to the fourth dx all over x squared plus 1. Okay, so for this problem, okay, so this integrand is quite tricky. So you need to be very observant of the integrand. Okay, so as you can see, we have here an improper fraction because the numerator is of higher degree than the denominator. If that's the case, then if the numerator has equal or greater degree than the denominator, then we can still perform division. Okay, so we have to divide it first before integrating. Okay, so divide x to the fourth by x squared plus 1. Okay, so x to the fourth divided by x squared, so we will have x squared times x squared, so that is x to the fourth, x squared times 1, so plus x squared, subtract, so we will have minus x squared here, so this will cancel out, so negative x squared divided by x squared, so we have minus 1, so negative 1 times negative x squared, so negative x squared, negative 1 times 1, so that is minus 1, and then subtracting, so negative x squared minus negative x squared, so we have 0, and then 0 minus negative 1, so we have positive 1. So 1 divided by x squared, so it's a proper fraction already, so therefore this will now be the remainder. Okay, so rewriting this, so this will become integral of the quotient, so you have x squared minus 1 plus the remainder over the divisor, so plus 1 over x squared plus 1, okay, dx. Okay, so using our properties of integration, so then we can integrate each term, so therefore we will have integral of x squared dx, and then we have minus, so 1 times dx, so we have minus integral of dx, and then plus integral of dx over x squared plus 1. Okay, so as you can see, we can integrate the first and second terms easily. So however, on the third term, okay, so on the third term, so we will be using here the inverse trigonometric function arctangent. Okay, so this is in the form of du over a squared plus u squared. So where our u here is x, and then our a is equal to 1. Okay, so as you can notice, we can't use the natural logarithm in here, okay, because for the natural logarithm, the numerator must be the complete differential of the denominator. Okay, and our denominator is x squared plus 1. Its differential is 2x dx. Okay, so since here we only have dx, then we cannot use that. Okay, so for 2x dx, so we can place 2 Okay, but we cannot place an x in here and then write 1 over x outside the integral sign. Okay, so that is not it's not permitted. Okay, if there's such a word, if permitted is the word for it. So writing x and then writing 1 over x outside the integral sign so is not permitted. So only constant coefficients can do that. Okay, so therefore we cannot solve this using natural logarithm. So that's why we look for another method to integrate that. Then we can use the inverse trigonometric function. Okay, so therefore integrating this, so this will become integral of x squared, so that will be x cubed over 3, or 1/3 x cubed, minus integral of dx is x, and then here we can apply now the formula. So 1 over a, so 1 over 1 arctan of x over 1 plus c, or simplifying, so we'll have 1/3 x cubed minus x plus arctan of x plus c. Okay, so for our last problem, so let's try this one. So integral of dx over x squared plus 6x plus 10. Okay, so this can be solved using arctangent, but first we need to transform the denominator into the form of a squared plus u squared. Okay, so to do that, so we can break down, okay, we can break down the trinomial in the denominator into a perfect square trinomial and a constant. Okay, so we have here the first two terms of the trinomial is x squared plus 6x, so we need to complete the square. Completing the square. Oops. Okay, so the last term in completing the square is equal to the middle term divided by 2 square root of the first term and then squared. Okay, so that will be the last term of this trinomial, so that it will become a perfect square trinomial. So the middle term here is 6x over 2, square root of the first term is x squared, and then squared. So if we simplify this, so x over square root of x squared, so we can actually cancel that out, and 6 over 2 is 3, so 3 squared, that is 9. Okay, so we need to break down 10, okay, into two terms, for which one term will be 9, so that we can complete this, we can complete the trinomial, okay, the perfect square trinomial. So this will now become integral of dx over x squared plus 6x, and then to complete the square, the last term should be 9, so plus 9. Okay, and then to make it 10, okay, so originally it was 10, then therefore we need to have plus 1 there. Okay, So see what we did there. So we just break down 10 into 9 and 1, so that this will become a perfect square trinomial. So x squared plus 6x plus 9, that is equal to x plus 3 squared, okay, plus 1 squared. Okay, so 1 is 1 squared, right? So therefore, our u here is equal to x plus 3. Then our a is equal to 1. Okay, so since the numerator, for us to use this formula, the numerator should be the complete differential of u. So our du from here, so since it's x plus 3, so therefore it's equal to dx. Okay, so therefore, since our numerator is already dx, then it's already complete. Then we can now apply the formula. So this will now be equal to 1 over a, so 1 over 1 arctan of x plus 3 over 1, okay, plus c, or this will now become arctan of x plus 3 and then plus c. Okay, so again, all you need to do is familiarize and memorize these formulas. Okay, so that it'll be easier for you to decide which integration formula to use. And also, of course, you have to keep practicing solving problems, so that you will easily recognize what type of integration shall be used whenever you see an integration problem. Okay, so that's all, and good luck with your assignments.